All right, so now we're going to look at combining shifts and reflections. So we have a graph of f of x. It's just this sort of piecewise thing shown in the graph, and we want to look at these transformations of f of x. So if you look at part A, the negative f of x, what does that do? That's going to reflect it across the x-axis, right? All of the outputs of the f of x become negative for the same x value. So this is a reflection reflected across the x-axis. Okay, and then we're adding 1 to it. So this is a vertical shift, right? So it's going to go up 1, right? Vertical means up and down. So we're just going to go up 1. All right. So we can take every point on this graph. Now you can see there are certain points that we can identify easily, right? So this is 1, 5, and this is looks like 2, 1. This point looks like it's 4, 3. And then there's a point over here, looks like 6, 3. Okay, so every point, we can basically take these points and run them through this new function and find the new points on the new on the transformed graph. All right, and we're just going to reflect it across the x-axis and shift it up by 1. So if we take this first point, 1, 5, right, we're going to reflect it across the x-axis, which puts it down here at -5, but then we have to go up 1, right? So the point on our new graph is going to be 1, -4. All right, same way here. 2, 1, we're going to reflect it to the other side, so it's going to be on the same distance from the x-axis on the other side, and then we have to shift it up by 1. All right, 4, 3, right? It's going to be reflected across the x-axis, and then we're going to shift it up by 1. So it looks like it's there. And then 6, 3, all right, it's going to go, we're going to reflect it, so it's going to be 3 below the x-axis, but then we have to shift it up by 1. So now I can connect those points. I'll just do it in green, I guess. I'll just connect those points, and you'll see what our new graph looks like. All right, so we've reflected, and we've shifted it, right? So now the new points here are 1, -4. This one is, let's see, where can I write it? 2, 0. This one is 4, -2. And this one is going to be 6, 6, -2. All right. So that's one way to do it. Another way to do it, I sometimes like all these shifts and reflections and all these transformations that we're going to learn. Sometimes I feel like it's a lot of memorization, and I always like to check myself. So if you forget the transformation, we know some points on the graph, right? So we know that we know x and f of x, right? And we could create a little table of those points. So when x is 1, f of x is 5. When x is 2, f of x is 1. When x is 4, f of x is 3. And x is 6, it's 3 still. Okay, so we're just taking those values from the original function. And now all of these, in this particular case, all of the transformations are on the output. All right, so I just need to transform the output. So all I need to do is take the negative of f of x and add 1 to it, right? So we're going to get, when f of x is 5, all right, the output of the new function is -5 plus 1, so it's -4. When f of x is 1, -1 plus 1, we're at 0, okay? When f of x is 3, then we get -3 plus 1, which is -2. And then when x is 3, or sorry, when f of x is 3, -3 plus 1 gives us a -2. So this gives us the same xy coordinates that I just graphed. So because now the new function is we're going to graph x versus minus f of x plus 1. All right, so you can see those points match up, right? So this first point, 1, -4, right? They match up with what we got. So that's just another way to kind of check yourself if you are ever not sure. Some of these are simple and sometimes they get a little complicated. And so I tend to sometimes not trust myself in remembering on how all of these shifts work, especially when you got a lot of stuff going on. And so sometimes I like to be able to check myself. So it's good to know how to do that. All right, so let's take a look at the next one. Here we have a reflection across the y-axis, right? We have f of negative x, that's a reflection. Reflected, oops, can't spell. Reflected across, oops, can't spell, across the y-axis, right? That's what the f of negative x does, and then we're going down by 4. Okay, so we have a vertical shift going on. All right, so I'm going to change pens and let's graph what that looks like. So let's do that in red. All right, so we're just going to take each point and translate it just like we just said. We're going to reflect it across the y-axis and then go down 4. So I'm going to reflect this 1, 5 across the x-axis, right? That would put it here at -1, 5, but then I have to go down by 4. Oops, 4. All the way down here, right? Okay, so there's the first point. Maybe I'll circle this so you know which one that goes with. The red goes with this graph. All right, let's do the next point. We're going to reflect it, right? So it's going to be the same distance on the other side, and then we have to go down 1, 2, 3, 4. Okay, and then we have another point. Let's do the 4, 3. We're going to reflect it, so it's going to come to 4 on the other side. 1, 2, 3, 4. And then we have to go down by 4. 1, 2, 3, 4. So we had a point there. All right, and then 6, 3. We're going to go 6 to the other side of the graph. We're going to come over here, and then we're going to go down by 4. So we have another one like this. All right, and then we just have to connect those lines. Okay, so we've reflected across the y-axis, and then we shifted it down by 4. All right, now again, you could come up with a table of values. Now the input is negative x, and the output is f of negative x, right? And those are, we know the input and output for those. So when negative x is, these same values, 1, 5, 2, 1, 4, 3, 6, 3. Those are the points on the original f of x, right? But now I need the input to be to match the values of that are valid inputs for f of x, right? So then what does x have to be on this new function? Well, this has to be -1, -2, -4, and -6. And then we're taking f of negative x, right? We're taking the output of f of negative x and we're subtracting 4 from it, right? So we're going to get 1, -3, -1, and -1. So those should match the points, right? This point here is -1, 1, right? Which matches the x and the f of minus x minus 4, all right? So down here, this is -2, -3, right? And that matches with what we found in the table. This is -4, -1, and this is -6, -1, right? So you can see they match with what we got in the table. So just a way to check yourself is all. So all right. All right. I had too many of these. It's going to take a while here. All right, let me use a different color. Let's see. What have I got? I figure out a different color. Let me go to a different color. Let's do a nice blue here. All right, okay. All right, so let's look at this next one. So here we're processing the input. This is a horizontal shift, right? And it's a horizontal shift to the left by 2. So this is shifting it left by 2. And then what this is doing is reflecting it across the x-axis. Reflected across x-axis. Okay, so we're going to shift it left by 2 and then reflect it. All right, so okay, we're going to go through all these points again and do that transformation across the x-axis. All right, so let's see here. we're going to let's see. We're gonna take this first point. We're gonna shift it left, right, to the left by 2, and then which brings us over to here, and then we're gonna reflect it across the x-axis. So that's gonna bring us down to -5 right here. All right. Then this one again, we're going to go left by 2 and then reflect it. This one here, we're gonna go left by 2, right, and then reflect it. So we're going to end up down here, go left by 2, and then reflect it. So we end up here. All right, my diagram's getting a little messy, but you can see now if I connect these lines, what the reflection looks like. So that's this one. All right, now I could go and check all of those you know, and with a table, but I think I'll I think I'll move forward here because I think this video is going to get a little long. All right, so I went ahead and drew out the table just so that you can see that the points do match with what we found by shifting left and then reflecting across the x-axis. All right, this next one is a little challenging, and it's only because, okay, what do we do first? We have two changes to the input. We got a -x and we've got +2. So, well, what does that mean? Do we shift it to the left by 2 and then reflect it across the y-axis? Or do we do the other way? Do we reflect it across the y-axis and then shift it left by 2? You'll get different answers depending on what order you do these, do those reflections and shifts. So this is where a table comes in handy. So what I'm going to do is just, I'll have to come back up to the graph, but we'll just go ahead and make a table. So the input to the function here is a -x plus 2. All right. And the output is going to be f of -x plus 2. All right, so the inputs I know are, 1 gives me 5, and 2 gives me 1, and 4 gives me 3, and 6 gives me 3. All right, that's just reading off the graph. All right, so now we have to think about, okay, what x value will give us a -x plus 2 of these values, these 1, 2, 4, and 6. All right, so all we need to do really is just, say, okay, what x value am I looking for? I have -x plus 2 is equal to 1, right? So let me scroll down a little bit. We'll, -x is equal to -1, so then x is equal to 1, right? So if I have an x of 1, that will give me a -x plus 2 of 1. All right, and I can do that for each one of these values. So if I have an x of 0, I'll get a -x plus 2 of 2. If I have an x of -2, right, then I would have a negative of -2 plus 2 gives me 4, and an x of -4 gives me 6. Okay, so those are just the x values that give me the inputs that I want to f of x, because those are the values that I know. I know the output for these inputs, right? So now I have xy coordinates, right? This is 1, 5. This is 0, 1. This is -2, 3, and this is -4, 3. All right. So those are the coordinate pairs, and then I can just plot them. So let me. It's a little challenging to get that on the whole on the screen, but I'm just going to plot those points. So the coordinate pairs were 1, 5, right? So that's 1. Whoops, 1, 5. Not that. And all right, 1, 5. Right, 1, 5 is actually corresponding to the point here, right? And then I had 0, 1. So 0, 1 is here. And then I had -2, 3. So -2, 3 is here. And then I had -4, 3. So that's here. And then I can connect these up. All right. So that's the answer. Now, in terms of reflections, it's a little challenging, and we're gonna talk about this a little more in 4.3. So don't worry if you don't not quite following this right now. But this is where the table comes in handy, because it's not clear what order to do the reflections in. So that's kind of why I like to I like to do the table method just to check myself. So it turns out that it's actually easier. Oops, sorry about that. To write this as f of negative x minus 2. So we're going to factor out a negative from the input, and then you can see that it is actually it's a shift to the right by 2, and then reflected across the x-axis, across the right, that reflects across the y-axis, right? F of negative x reflects it across the y-axis. Okay, so that's actually what it is. But that's where it gets a little confusing, and I like to use the table. All right, well, that was a long video, and that's all I have for that problem. So I'll meet you in the next video to talk about symmetry and even and odd functions.